I am Bhargavi, working as Assistant Professor in the Department of Information Technology, B.B. Raju Institute of Technology, Hyderabad, Brazil. So today I would like to discuss about a topic of NumPy library. So generally, what is a library? So library is nothing but it is just a chunk of pre-written code which can be used by the programmer in our projects. So in our programs and in our projects, we can use the pre-written modules, pre-written functions for particular task. So a Python library is a reusable chunk of code that you may include in our projects. So a library generally is a collection of modules and functions that can be utilized to perform a specific task. So generally in Python there is a vast ecosystem of libraries. So Python is providing a vast number of libraries, so which can be useful for a programmer to develop their projects in many kind of fields. So it has a vast ecosystem of libraries that cover a wide range of domains like machine learning, deep learning, data manipulation, data visualization, and data science, and quantum computing, scientific computing. So in such a various fields, we can use these libraries for performing our tasks. So to use a library in a Python, we just want to import that library first. So we can import a library in a Python using the import statement. So import statement followed by library name, which helps us to import any library into our program. So once we import our library, we can access the classes, functions, modules, variables, whatever providing by a library, we can utilize those things in our program, in our code. So generally how to import. So here is an example for importing a math. So here math is a library which performs some mathematical operations. So all the mathematical operations, square root, power functions have inbuilt. We need not to write any logic for the square root and for the power function. We can directly import that functions into our code. So for that first we need to import that library. So here I am importing import math. So whenever I use this statement, then all the modules, functions, variables, classes in a math, I can access in my program. My program. So how to access is, so if you use math, here I am using a pi variable with the help of math class name. So math.class name, so that I can access the pi value 3.14. So instead of using a math module, so I can write it down as import math dot as m. So if I write the statement like import math as m, so I can import m.pa. So here I am giving alias name for the math. So whatever the functions I want to use from the math library, I can use the name convention m for that instead of math. So here this is an example for finding an area of circle. So here I need a pi value and as well as I need a power value. So r square I need to calculate, radius square. So here the formula is 3.14 into r square. So for this I am using a predefined function, that is a power function, and I am using a predefined variable, that is pi value, which already have a constant value of 3.14. So I am using these two. These two are available in a math library. So first I imported a math function, then I have assigned the radius value equals to 5. Area I need to calculate. I am extracting a variable pi, so that math.pi into math.power of radius comma 2. So I am printing area. So with this we can import functions from library. First of all, we need to import that library into a program using import statement. So there are so many libraries are available in a Python for performing various projects in a various domains. The top standard libraries are NumPy. These are some of the standard libraries most frequently used for using a projects. So NumPy. So NumPy is nothing but a numerical Python which is used for array operations and the numerical operations. If we want to perform array operations and numerical and mathematical functions, we can use NumPy. Pandas is used for the data manipulation and for the analysis of libraries, data structures like data frames. For data manipulations, we use the pandas. A matplotlib is for it's a plotting library for creating static and interactive visualization, and as well as it is useful to create an animated visualization. So if I want our data it should be represented in a graph formats like charts formatted like a plot, we can go with the matplotlib library. They have inbuilt functions to design our project results in a graph format, plots format, by charts, histograms, whatever we can draw based on our results. So visualization purpose, we can go with data visualization, we can go for the matplotlib. So scikit-learn is used for is a machine learning library tool for classification, regression and clustering. So for that algorithms, we can use this machine learning library tool is scikit-learn. So TensorFlow is an open source machine learning framework for building and deploying deep learning models. So PyTorch is a deep learning framework. So for flexible and dynamic computation of graphs, we can go with the PyTorch. So Keras is a highly neural network application programming interface. So it will be built on top of the TensorFlow and have a fast prototype and experimentation. So Flask is for the web-based. For developing any web-based applications, we can go with the Flask library. So corresponding functions for the web applications, we can go use import Flask library. So OpenCV is for the computer vision library for image processing and for pattern recognition. So whatever the necessary modules we need, we can get it from the OpenCV library. So NLTK is a natural language toolkit library for processing a human language. For natural language processing, if you want to process the natural languages like Telugu, English, Kannada, Tamil, Malayalam, so for processing all these natural languages, so the corresponding modules functions will be available in the NLTK library. We can import that NLTK library for NLP. So SciPy is for the scientific and technical computing, providing modules for signal processing as well as a linear algebra and for optimization. It provides modules for the optimization. So this is scientific library. So here these are some of the standard Python libraries. So Python libraries were used to create applications and models in a variety of fields for machine learning, data visualization, image processing and for the data manipulations and many more. We can import these libraries. So first we'll see about what is a NumPy. So NumPy is an open source library which is available in a Python, which helps for mathematical calculations, scientific calculations as well as for the arrays. So mainly NumPy is used for the multi-dimensional array creation. We can create multi-dimensional arrays, and for scientific and mathematical calculations, we can use the NumPy library. It is perfectly translated into a C, C++, Fortran. We can easily integrate this into a C, C++ and a Fortran language. It is very useful library for the mathematical and the scientific operations in a Python. So we used to build for 9-dimensional array, linear algebra and random numbers and Fourier transform, etc. So Python NumPy library helps us to build all these things. So how to install this NumPy? So generally we have an integrated development environment softwares like Jupyter, Anaconda, PyCharm. So some packages, some libraries or by default will be available in that software. So if we are using a Python ideally, so explicitly we need to install the corresponding packages. So how to install these packages in our ideally? So using pip. With the help of a package manager pip, we can install a packages libraries into our program, into our ideally. So how to use? So this is a syntax. Pip install NumPy. Whatever the package. Here you can use SciPy, Matplotlib. So whatever the package you want to install, you can install using a pip space install space what is the corresponding library name. So generally from the earlier versions of a 3.4 there is no pip at all. For pip purpose also we need to install that pip. Pip is a preferred installer program. So we need to do that also. But from the 3.4 later versions onwards, pip is already available by default. With the help of a pip, we can install our package, our libraries, NumPy, scipip, matplotlib, TensorFlow, whatever. So to uninstall also we can use a pip like pip uninstall NumPy. But this thing has to be done in the command prompt. So here is the command prompt. We should go to the location of this. So whenever we install a Python, we have a Python folder. In Python, we have a Python bits, and we need to go for the scripts. Then there you can see that file like pip.exe in scripts folder. So we can use that path for installing any libraries. So this everything should be done in a command prompt for installation. Whereas in IDE software, integrated development environment softwares like Anaconda, Jupyter, PyCharm, they by default it is there. If some packages were already available, some libraries are already provided. If not, if we need any extra, externally we need to import. Externally we need to install those packages in the IDEs also. So pip is a major thing, helps us to install these libraries. So what is a NumPy? NumPy is important library generally used for, these are the main places where we can use this NumPy library: machine learning, data science, image and signal processing, scientific computing, quantum computing. So how to import this NumPy? So far we have seen how to import math, right? So in the same way we can import NumPy also using import space NumPy. Here I am using alias name as np. So import NumPy as np. So whatever the functions and variables I am using from the NumPy, I have to call it by using np. So after the import statement, we can use the NumPy functions and objects by calling them using a np. Suppose there is an array function in a NumPy, I'll call that function using np like this: np.array. If I don't mention as np here, I have to call it as numpy.array. Like this, we need to import the functions of the corresponding NumPy. So what are the NumPy data types? Generally, data types are used to store the type of data we are storing. So for that representation, data type is helpful. It is way to specify the type of data that we will be stored. So there are some data types. So generally Python have a data types like int, float and complex data types. List, tuple, these are also data types. Here what is the built-in data types for a numerical data? So NumPy is providing us several built-in types of data types for numerical data. So these are the commonly used numerical data types in a NumPy: int 8, int 16, int 32, int 64. These are the signed integers of different bit sizes. Like uint 8, uint 16, uint 32, uint 64. These are the unsigned integer type of the corresponding bit sizes. Float 32, float 64 is a floating data type of corresponding bit size 32, 64. Complex 64 and complex 125 is a complex data type of the different precision values, that is 64 and 128. So to check the data type, so generally in a Python we used to check the data type like a is equals to some 10 I have given. So a is equals to 10 I have given. So type of a, if I mention, I'll get class int. So like this I'll get. So whereas here, how to check the data type of NumPy array? Using d-typed attribute. With the help of a d-type attribute, we can check the type of NumPy array. See here I am creating, first I have done import NumPy as np. Next I have created an array. array of 1 is equals to, using array function np.array, inside I am passing a list. So now I am checking print of array 1 is a variable, array 1 dot d type. So it will give output as, it is a integer value. The list is having integer values, it gives int of corresponding bit size in 64. So generally we used to check the type with type of, whereas in NumPy we were using d type along with dot operation. So that is the difference. So now how to create this NumPy array? So generally NumPys were used for matrix multiplications and n-dimensional array creation. So main purpose of NumPy is for the arrays. So we have a list, why we have a list in a Python, why we need to go for the NumPy array. So when compared to the list, NumPy array is fast, more efficient, and NumPy arrays have a special requirement of a homogeneity collection of elements, whereas a list we can store any type of values, whereas an array it stores only homogeneous elements. So string of array contains only string values, integer of array contains only integer values. So here arrays allows us to store a collection of multiple values in a single data structure. A NumPy array is similar to a list, but the slight difference and what is the benefit when compared with the list is it is faster and more memory efficient when compared with the Python list. But in array function we are passing a list only. So here creating an array. How to create an array in NumPy? Using array function only. Using array function. That function is available in a NumPy. So first I need to import a NumPy. Import NumPy as np, as alias name as np. So next onwards, whatever the inbuilt functions I am using from the NumPy, I have to call it with np. Like np.array. np.array of and pass the list. So now it has created an array. Print of array 1, so it has created an array. So unlike list, array cannot store any type of values. It stores only a similar type of values. How to create an array with 0 values? So I need a 0 values in my array. How to create an array with 0? So all the zeros will be filled in an array with the help of a function np.zeros function. np.zeros functions allows us to create an array filled with all zeros. So first I have imported that zeros function is available in a NumPy. So I have imported import NumPy as alias name np. Now I have created a 4 elements filled with 0. For that I have used array 1 is equals to np.zero function, and I have to fill only 4 zeros. Now print array1, array 1. So I will get this as an output. So we can use the zeros function for filling array values with zeros. How to create an array with the range function? So generally, what is a range function? We have Python, we have a range function. So range function is used to provide a sequence of elements within the range. So if I give 5, so I'll get a sequence of elements like 1, 2, 0, 1, 2, 3, 4. So I'll get these elements 0 to n minus 1 value sequence can be generated with the range function. So likewise, arange is also same for array range. So array range function returns an array with values with a specific interval. With a specified interval, it generates the values. So this arange is an NumPy function. So first we need to import the library import NumPy as alias name np. So whenever I am using arange along with the alias name np.arange, and I passed the 5 value. So in array 2 also I have given np.arange of 1, 9, 2. So this is a starting range, and this is the end of the range stop, and this is the step size incrementing. So if np.arange of 5 means it will generate a values like 0, 1, 2, 3, 4. 0 to n minus 1. So what will happen if I give this start, stop and step sizes? So it has to start with 1 and has to end with 9 value, and the step size is 2 means it has to increment 2. So like 1, 3, 5, 7. So the last number should not be included, it will take n minus 1. So this will be the output. So random number. So we can use create a array of random numbers using NumPy library. So in a NumPy library, we have a function of random.rand function, which is used to generate a random numbers, So how many numbers we want to generate, we can give that value inside this function. So here first I have imported a NumPy to get access of the random.rand function. So then I've taken a variable array1 is equals to, so np.random.rand of 6. If I mention this and I've tried to print off array1, now I'll get a random numbers of 6 random numbers I'll get. So I'll get 6 random numbers. So for random number generation also the NumPy array will be used. So NumPy n-dimensional array creation. So generally NumPys are used for creating a multi-dimensional array. It is not restricted to the one-dimensional array. So it allows us to create a two-dimensional array, three-dimensional array and n-dimensional array. An n-dimensional array represents a number of dimensions in which array is organized. So there can be any number of dimensions, and each and every dimension can have any number of elements. For example, in a two-dimensional array means that it is in a table with rows and columns. If a three-dimensional array means it is a cube with width, height and depth. Likewise, n-dimensional array represents number of dimensions in which array is represented. So let's create a two-dimensional array. So for creating a two-dimensional array, we have an array function only. So that can be used with the alias name np.array, and I have created a two-dimensional array. This is a row, 2 rows and 4 columns. So print of it. So to create a multi-dimensional array from the scratch, we can use the functions of zeros, arange and random numbers. Using these functions also we can create a multi-dimensional arrays. So generally all these dimensions were created by using the array function only. All these were created by using array function only. Here in the array function we need to give whether it is a 1D, 2D, 3D or n-dimensional array. So here is the example for the one-dimensional, two-dimensional and a three-dimensional. One-dimensional array with 4 elements and two-dimensional array of 2 rows and 3 columns, and the three-dimensional array with width, height and depth. So what is a NumPy attribute? So NumPy array is having some attributes. Attributes is nothing but the properties of a NumPy array. So that provide information about array size, shape, data type, dimensions of an array. So all this information we can get. So attributes is nothing but a properties of a NumPy array, which gives us some information about regarding shape, size and dimensions. For example, I need to get a dimension of an array, whether it is a 2-dimensional, 3-dimensional or 4-dimensional or n-dimensional. So to get a dimension of an array, I can use the attribute of ndim. Ndim is attribute helps us to get a number of dimensions are there in that array. So it is available, this attribute is available in a NumPy. So there are numerous attributes are available in a NumPy. For example, these are some of the attributes are available in the NumPy. Ndim, it returns number of dimensions of the array. It returns number of dimensions of the array. Size will return number of elements in the array. Dtype will return the data type of elements. So if I give elements like 1, 2, 3, this is an array. So it returns that int of 64. What is the data type of the elements in the array? So shape will give the size of array in each dimension. So item size will give the size of each element in the array. It returns the size of each element in the array. So data will give us the actual elements in the array. So actual elements in the array of memory. So it will return by the data. So NumPy attributes. So NumPy array attributes. So all these attributes like we have seen ndim, size, shape, these are all used by using a dot notation only. So with the help of a dot notation. So here I just want to see how many dimensions are there for this array. I just want to find number of dimensions for this given array. So first, this attribute is available in a NumPy, so I need to import NumPy, and I am giving alias name as NumPy as np. So I am creating an array. Array 1 is equals to, using array function, np.array, and I am giving two-dimensional array. So 2, 4, 6, 1, 3, 5. So I am giving two-dimensional array. You can see the square brackets. So I am checking that how many dimensions. This is a two-dimensional array. You can see the braces. So print of, that is stored in ARR1. I just want it. So use a dot notation, and ndim is an attribute which gives us number of dimensions. So here we have is a 2 dimension. If it is like this, it's a 3-dimensional array. With the help of ndim, we get number of dimensions. So what is the size attribute? So size attribute in a NumPy array, it will give the number of elements in the array. So with the help of size, so np dot array, there is an array 1, 2, 3, 6, 7, 8. So I just want to get size, right? Print of, this is array variable, array 1 is equals to, here or 1 is dot, with the dot notation, so I will get size. So how many elements? 1, 2, 3, 4, 5, 6. So output will be 6. So number of elements in the array. So that is going to give by the attribute of size. That is need to be imported from the NumPy. So shape. What the shape attribute will give? Shape attribute will give a tuple of integers that gives the size of an array in each dimension. It will give a tuple of integers that will give a size of array in each dimension. See here is the same example, NumPy.array. I have created a 2-dimensional array. So what is the shape of this 2-dimensional array is, it is giving output as 2, 3. So it is 2 rows, 3 columns. So it returns a tuple of giving size of an array in each dimension. Array indexing. So generally we have a list in a Python. As a list of a Python is represented with the index, we have an indexing concept in a list to represent each and every element have some specific number. So that number indicates the index of the corresponding element. So likewise here also each and every element in an array is associated with a number. So that is the array index. With the help of array index, we can access the elements. So here for example, this is a function np.array of 1357. So if I give array 1 is the variable which is storing that one, array 1 of 1. So this is a 0, 1, 2, 3, 4. So array of 1 I can access the value of, for the first index is 3. Array of 4, array 1 of 4. So I will get the fourth index value 9. Array 1 of 5. So there is no element. So it is array index out of bound error. Array index out of bound error. So indexing concept also there in a arrays, as well as slicing also there. We can extract some portion of array elements using a slice operation with the code, like we have done in a Python list also. So these are the some of the NumPy operations. So that is add of x comma y used for the addition. So to call this add of x comma y, I need to give NumPy dot add of x comma y. So as well as a subtract for subtraction, divide for division, multiply for the multiplication, all these things need to be used with the NumPy dot add of x comma y, or if you are using import NumPy as np, then I can use np dot subtract of x comma y. So this is the square root, np dot square root of x, getting the square root value is the element wise sine, element wise cosine is a logarithmic operation of log, and dot of x comma y for the dot product, and roots for roots of giving a polynomial coefficient. For this coefficients it will give the roots. So this is about a NumPy operation. These are all some of the basic information about the NumPy. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.